Hey geometry team, it's Mrs. Cerna here and welcome to Unit 9. We're going to be focusing Unit 9 on area. Now we are going to do a little bit of perimeter stuff just to remind you of that thing you did way back when you were little kiddos, but we are going to be focusing mostly on area. And to start things off, since we just finished a whole lot of good stuff on circles, we're going to spend some time looking at the lengths of arcs and the areas of sectors inside a circle. You said, wait a minute, area of sectors, you just said area, but arc length, that is having to do with the outside of the circle. So let's get into it and talk about what we've got here. So here's all our parts of a circle here. So you had your radius. You knew what that was. It goes from your center to your edge. It's the same size anywhere it is in the circle. This is always the same distance. You've got an arc, which we're also familiar with. It's a portion of the circle itself that we've been doing measures of, figuring out how many degrees it is. This unit, you get to look at the lengths of that. We're going to actually use inches and feet and all that kind of stuff again. Then we're going to get into the area pieces. And so a sector is the area of a wedge of a circle. And so it's enclosed by a couple of radii there, and we're going to be working on finding areas of that. And then we're also going to chop off the round part of a sector, and we're going to call that a segment. We'll find that too, just for extra fun. And to do all these things, there's also going to be this little dude, okay? He's going to go from the center to this chord, and that's called an apothem or an apothem. Apothem or apothem, and I can never tell which one's the right way. I think both are okay. We're not going to spend as much time with him today. He's going to show up later, but didn't want him to be left out. So to start off with, let's look at what the circumference of a circle is. Let's remind ourselves what that is. And so a circumference of a circle is just going to be your perimeter of a circle. And so it's just the distance around the outside. And if you've paid attention in the last couple of years, you've had these formulas. So you've either said that the circumference is 2 times the radius times pi, or sometimes 2 pi r. Or sometimes instead of 2 times the radius, you've said, wait a minute, 2 radii are just a diameter, and so you've done pi times diameter. Both of those formulas are exactly the same thing for finding your circumference. And so an example, oh look, a circle, it's got a radius of 5. And so in order to find its circumference, I will either use 2 times the 5 and get 10, or I will use the diameter, which is 10. And so let's find our circumference. I'm going to use 3.14 for pi because pi goes on forever and is annoyingly long, so we tend to round off here at 3.14. So we'll use that for pi, and we're going to use our 5 for our radius. So 2 times that will give me 10, and then times by that 3.14, my circumference is going to end up being 31.4 feet. And so, yay, you found the circumference or perimeter of this circle. You're very impressed. Now, what will happen now if I change that radius? I've made it into 10. So I just doubled my radius. So what happens if I double my radius here? I want that, there it is. What happens when I double my radius? Well, when I double my radius, instead of having a 10 in here, I have a 20, which is twice 10, okay? And so my diameter became 20, and so pi times my 20 now is going to give me a circumference of 62.8. Question though. The old radius was 31.4. Or sorry, my old circumference was 31.4. Don't look at that. That's supposed to say circumference. So my old circumference was 31.4. When I doubled my radius, now it became 62.8. And so I doubled my radius and I doubled the circumference. And that may be a little harder to see than I expected it to be up here on the board. But this just tells you that if you double the radius, you double your circumference. Fun. Good little relationship to know about. Lots of things like that happen in math. And so now we're going to talk about just an arc. How can we use that circumference we just found in order to find the length of an arc? And the thing you have to remember is that if the circumference is the distance around the full circle, an arc is just a fraction of it. It's a part of the circumference. And so in order to find the length of an arc, we're going to take the circumference and figure out what fraction of the circle it is and work with that. And so we start off by going, okay, I'm going to name this middle angle, instead of calling it X or calling it Y, that gets boring. And so mathematicians like to use this Greek letter theta for angles. And so we're going to transition. I'm going to use theta a little bit more. So theta is going to be just the variable for my central angle. Okay? And so my formula is going to be for my arc length, for however long this green arc is I'm going to take my circumference, which is 2 pi r, and I'm going to multiply it by whatever fraction of the circle I have. Now, a whole circle is 360 degrees, and theta is this little piece of the circle I have out of 360. So in this example, to find this arc length, I'm going to think, wow, I have 80 out of the 360 degrees in the circle. That's what I'm going to use in my formula here. So to find my arc length, I'm going to go 2 times pi times my radius, and then I'm going to go, okay, I have 80 out of 360 degrees in the circle. So this is the fraction of the circle I have. This is the length all the way around the circle. When I multiply those, that will give me my length of my arc. And so when you work all that out, the 31.4 ended up being my entire circumference. When I do this fraction, it's 0.222222222, so I rounded it off. And in the end, you end up with an arc length of 6.97 inches. So this actual length now is 6.97 inches. Its measure was the 80 degrees, but its length is 6.97 inches. So now we're getting into finding actual numbers and amounts instead of just the number of degrees. You're very excited, I can tell. So an example, you're eating some pizza. Now, if you're like me, I don't like to eat the crust. Whatever crust I have left, I usually reach over and smack one of my kids on the head with it, or something equally obnoxious, or you dip it in your marinara or some other delicious sauce. So I want to know if the amount of crust, the length of crust I have is enough that when I dip it, my fingers don't get covered in sauce. So here it is, angle PZA. Angle pizza is going to be 60 degrees here. Okay? And the radius of my pizza is going to be 10. Now, I'm going to assume that's 10 inches because honestly, a 10-mile long pizza would be amazing, but a bit too much to eat. And so I'm going to be working with this. So I've got a 10-inch radius pizza all to myself and a 60-degree piece. And I want to know how long this piece of crust is going to be once I've eaten out all the pizza. So I know that if when I dip it, my fingers are going to get sauce all over them. So I know that to find my arc length, I'm going to take my circumference times the fraction of my circle I have. So let's see what I've got here. So my arc length is going to be my circumference times the fraction of circle, just like we've always been doing. So my 2 pi r will now be 2 pi, and my radius was 10 inches. And I know that I have a 60-degree angle out of 360 degrees. This is 1/6 of a pizza. Work all the numbers, and my arc length ends up being 10.47. And of course, I would never leave it naked. So if this was a 10-inch pizza, my crust is 10.47 inches, which is plenty long for me to dip in the little cup of sauce without getting my fingers covered in sauce. So I am very happy with that. Don't want to get sauce on my hands. You know, with Corona and stuff, you got to clean everything. It's annoying. All right, so that was lengths. Now we're going to go in and talk about areas in circles. And so the area of a circle is going to be the number of squares covered by this two-dimensional object. And so you can imagine filling this thing with squares and then counting how many squares are inside. That's what you're doing when you're finding area. And so for a circle, the formula is area equals pi r squared. And you're like, wait a minute, no they aren't, pi's are round. But no, the formula is pi r squared. And so we're going to find its area using this formula. Okay, so we're going to still use 3.14 for pi, and we're going to use our formula, and here's that same old circle with 5 centimeter radius here. So, in case forgotten since 6th grade, I will take pi times my radius squared, so 5. I square that and get 25, multiply it times my pi, and my area is going to equal 78.5 centimeters squared. Now remember, since I am finding the number of squares that fill up this object, your units always need to be in square units. Even though we're doing circles and even though they're round, we're always counting the squares inside. Okay? So now, what if I had that circle with 5 centimeter radius and doubled it? Now it's 10 centimeters wide. What happens with my area then? Well, it's going to get bigger. I'm going to have a much bigger number of squares inside. Let's see what happens when we do that. So I've doubled my radius now, and so now it's 10. I square that, and it's going to go up to 100. And so my area is now going to be 314.1 centimeters squared. How does that compare to what we had before? Well, previously, my area was 78.5. Now, my area is 314. That's 4 times bigger than it was before, instead of just being doubled. This happens anytime you do area of stuff. If you double the radius, the area gets 4 times as big. If you triple the radius, it gets 9 times as big. It multiplies by 9. If you do 4 times the radius, the area is 16 times bigger. Why is this? And the reason why comes down to this little squared guy. If I had double my radius in here, that doubling gets squared. And if I triple that radius, that 3 gets squared into a 9. And if I quadruple my radius, it gets squared and becomes a 16. And so all those doublings or triplings get squared so that your area gets much bigger, much faster than your circumference does. Imagine what happens when we do volume in cubes. Ooh, that will be exciting, but you don't get to know that yet. Instead, let's look at sectors now. So a sector is the area of a wedge of a circle. It's outlined by 2 radii, and so it's just a chunk, piece of the pie, and you would be finding just the area of that. The area of a sector works the same way as the area of an arc, the length of an arc. And so the area of my sector, again, we're going to focus and figure out what the whole circle area was, and then say, nah, I just want a fraction of it. And so I'm going to multiply by whatever fraction I want to figure out how big just this little wedge is. So sector's just a wedge. Once again, theta is my symbol for an angle. We're going to just use him again. And in this case, my central angle theta is 80 degrees. And so, okay, if I do that, my sector area is going to equal the area of a circle, pi r squared, times my fraction, which is going to be that theta out of 360 degrees. And so my radius is 5, so I drop 5 into my formula. And then my theta, my central angle, is going to be 80 degrees. Because that's what the picture says it is. And so calculator, math, and you come out with 78.5 times 0.222. So this was the area of the full circle, but I only want this much of it to do that wedge. And when you park that all into your calculator, you end up getting 17.4 square inches for the area of just this wedge of your circle, 80-degree wedge. If you make a bigger wedge, you get a bigger amount of area. Okay, so, piece of the pie. I want some pie. So, how much is this missing piece? Somebody ate a big chunk of my pie. I want to know how much that is. And so, I've got angle pi here, P-I-E, is 80 degrees. So, they took almost a quarter of my pie. Darn them. And this was probably a good pie, too. And now I'm missing a piece of it. And so the radius, this is an 8-inch pie. Normally I make 9-inch pies, but in this case, apparently I bought an 8-inch pie. And so I want to know the area of this sector that got taken out. So I'm going to need to find the area of the whole circle and then the fraction that is gone. And so you go, okay, the area of my circle is going to be pi times my radius squared. My radius was 8. That's what we found out before because it's my 8-inch pie pan. And then I've got 80 out of the 360 degrees is the degree of this central angle. And so 80 out of 360 comes out to 0.222. My area was 64 pi, or 64 times pi, and I end up with 44.64 square units. If it's an 8-inch pie, this would be square inches. Okay, so that's how much pie I'm missing out of my pie. And I want my pie back. I like using pie because, pie, delicious. Remember, Pie Day is March 14th, 3.14. It's over spring break. Celebrate with some pie. Okay, last little piece we're going to have here is going to be a segment. And so a segment is where you take a sector of your pie or whatever circle you have, and you say, I just want to know the area of this little piece right here that I cut off the edge. And so in this case, that's the part that's got the frosting, because that's the good stuff. And so I want to know the area of just the frosting part of this cookie. That's called a segment. Well, that segment is just going to be an area of this sector, this green part, minus the area of this pink triangle. So the blue piece is what I want to find the area of. So I'm just going to find the area of my sector and subtract the area of my triangle to get the area of my segment. And I don't know why they call it a segment. We already have that for these little, line segments. But we call it a segment when you just have this little curly piece on the end. Sorry about the double words. It's not my fault. I didn't choose them. Okay, so in this case, I'm going to have a 12-inch radius cookie. This is one of those big old cookies. An 80-degree part that is being measured off here. And this length of this cord that I'm cutting off is 16 inches long. And I want to know the area that got cut off the edge there with all the frosting. So to do that, I'm going to take my sector minus my triangle. So let's find the area of my sector first. So the area of my sector is the area of the whole circle times the fraction of the angle. So it's going to be 12 is my radius squared, and then I have 80 degrees out of 360 that I'm measuring and cutting off. Work, 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 and I end up with 100.53. I didn't have units here, but we're going to assume that those are square inches because I had inches on my cookie. Then I need to find out the triangle because I don't want that part. It doesn't have frosting. So I want to cut that off. So let's find its area. The area of a triangle is half base times height. And so my base here is this 16 inches along the bottom. And my height is going to be this little piece right here. And I've said 12 here, but that's wrong. That's my apothem, and my apothem is not the same as my radius. So I'm going to cut that off, and I'm going to say that that's actually, instead of 12, I'm going to say that's 10. And so I'll have my 1/2 times my 16-inch base times my 10-inch height. Okay? And that's a little 2-inch piece left behind with some yummy frosting on it. So when I work that out, I'm going to have 80 for my area of this pink part. So this pink part here is going to be 80 square inches. So now to find the area of the segment, I need to take the green sector and subtract out the pink triangle to get this little blue frosting piece that I want left. So I'm going to do the 100.53 minus the 80 square inches, and that's going to end up giving me, and this was supposed to be 80 here because Ms. Cerna cannot number, so minus the 80 is going to end up giving me 20.53 square inches. And I have units squared here because for some reason I did not pay attention to the fact that it was inches, but it makes my area be in inches squared. So I have 20 little square inches of frosting here that I get to eat out of that little segment of my circle. So, okay, let's recap. I have circumference is the distance around. Arc length is a piece and the length of that circumference, that is just a small piece. I have a sector, which is a piece of the area of a circle, and I have a segment, which is just this rounded part of a sector after I cut off a triangle. So good luck with your formulas, and we'll see you for day 2 next time.